Okay, now let's take a bunch of derivatives. So I've got this guy here, f of x is square root of 5x squared minus 8x plus 1. I want to find its derivative. Anytime you have any kind of radical, rewrite it as a rational exponent. So before I even start taking derivatives, I want to think f of x here is 5x squared minus 8x plus 1 to the 1/2 power. Square root is 1/2 power. So I haven't done any derivative yet. I just rewrote the function as an exponent with a fraction exponent. Okay, then the derivative, f prime of x, will be, and I'm going to write it out, the derivative of the outside evaluated, so I'll write here evaluated at the inside, not times. Here's my times. The derivative of the inside. Okay. So let's think just for a minute. Forget about all these guys. If I had y equals x to the 1/2, then what would his derivative be? That's just power rule. The power will come down to the front times x times 1/2 minus 1. 1/2 minus 1 is negative 1/2. So this is what I'm going to use to find the derivative of the outside. I've got this function. That 1/2 is going to come down front. Leave the inside alone. My new exponent is negative 1/2 times the derivative of the inside. And here it's just a whole bunch of power rules and sum rules. What do I get? 10x minus 8. Derivative of 1 is just 0. And maybe I could clean this up some. Maybe I couldn't. Don't really care at this point. Okay, let's do one more in this video. I could do this problem using quotient rule, but I'm going to have to use chain rule at some point anyways. So I think it's much easier to think about this guy using negative exponents. Rewrite this as 3 times 4t plus 2 to the negative 2/3 power. So I brought this whole denominator up and made the exponent negative. It's just rules of exponents. Then his derivative with respect to t is my independent variable here, will be, the 3 is just going to come along for the ride. Remember, anytime you're taking a derivative, constants times a function, the constant just comes along for a ride. Times, I've got something to a power. The derivative of anything to a power is you bring that power down front, leave the inside alone, and then drop that power down by 1. So over here on the side, I'm going to think negative 2/3 minus 1 would be negative 2/3 minus 3 more thirds. That's negative 5/3. Times, here's where people make mistakes. Don't forget about this. Times the derivative of the inside. The derivative of 4t plus 2 with respect to t would just be 4. The derivative of plus 2 is just 0. So derivative of the outside, leave the inside alone, times the derivative of the inside. And here, let's go ahead and clean this up a little bit. Those 3's will cancel. I'll get 2 times 4 times a negative, so I get -8 4t plus 2 to the -5/3. And like, just for fun, we could just leave it like that. That would be fine. Let's go ahead and get rid of that negative exponent by bringing that guy back down to the bottom and making that a positive exponent. That's just rules of exponents there. And then if we wanted to, remember, a rational exponent just means you're doing a power and a root. We could, if we wanted to, rewrite this as 4t plus 2, the cube root of that. And then once we do that, we take that all to the 5th power. But honestly, I was happy when we got here. It's a good place to stop there.